Assalamu alaikum dear students. Today we will study inshallah refraction of light, laws of refraction of light and total internal reflection. First of all, we study about refraction of light. Before starting its definition, we take three examples, three observations in our daily life. Students, you have observed that if we dip a pencil into this water, when we dip this pencil into this water, it looks bent like this. Why does it happen? Number two, why the position of the fish under the water seems to be at less depth. Number three, why the depth of swimming pool looks less. In all these three observations, that happens due to refraction of light. Because refraction of light, the process of bending of light as it passes from one medium to another. Because when light passes from one medium to another, it changes its direction, it changes its path, it deviates, and this changing, this bending, this deviation is known as refraction of light. Number two, we study a short question. We study short question, laws of refraction of light, in which first law is incident ray, refracted ray, and the normal at the point of incidence all lie on the same plane. Number two, as shown here, number two, n is equal to sine I over sine r, where n is equal to refractive index and there is a constant ratio between angle of incidence, sine of angle of incidence to the sine of angle of refraction, and this constant ratio is known as refraction of light. Second law, the ratio of the sine of angle of incidence to the sine of angle of refraction is always constant, and this constant ratio is known as refractive index. It is denoted by n. And students, this second law is also a definition of refractive index. Itself is definition of refractive index, and it is also known as Snell's law. N is equal to sine I over sine r. This is Snell's law. It is also known as Snell's law, and it is conditional. N is equal to sine I over sine r if light enters from rarer to denser medium. Then n is equal to sine I over sine r. Once again, this n is equal to sine I over sine r when light enters from rarer to denser medium. But if light enters from denser to rarer, then n is equal to sine r over sine I. Again, I am repeating, if light enters from rarer to denser, then refractive index is equal to sine I over sine r. And if light enters from denser to rarer, then refractive index is equal to sine r over sine I. Another short question we study. Right, students, next short question. Write four formulas of refractive index. First formula, n is equal to sine I over sine r, and you should write in the bracket that light enters from rarer to denser medium. This is first formula, n is equal to sine I over sine r. Number two, n is equal to real depth over apparent depth. Number three, n is equal to speed of light in air over speed of light in medium. And number four, n is equal to 1 over sine c. C is capital here, and C for denotes for critical angle. These four formulas are here. N is equal to sine I over sine r when light enters from rarer to denser medium. Second, n is equal to speed of light in air over speed of light in medium. Medium mean glass, water, whatever, you can use the medium. Number 3, n is equal to real depth over apparent depth. Number 4, n is equal to 1 over sin c. Once again, we have studied today refraction of light, laws of refraction of light, and we will study after few minutes total internal reflection. And now we study total internal reflection. Look at the board. This is a surface of denser medium. You may assume this is water or this is glass. This is glass. And this is air, which is a rarer medium. These two are mediums, glass and air, and comparatively air is rarer medium than glass. Suppose this is a source of light. When this incident ray fall on this glass surface, it bends away from the normal. It bends away from the normal. Students, again I am repeating. This is a glass surface. This is air. And it is a source of light. It is an incident ray. When it falls on the denser medium, it bends away from the normal. This is normal. This is angle of incidence and it is angle of refraction. And when light enters from denser to rarer, it always bends away from the normal. If we increase the angle of incidence, angle of refraction also increases. And at a particular value of angle of incidence, the angle of refraction becomes 90. At a particular angle of incidence, the angle of refraction becomes 90, and now this angle of incidence is also known as critical angle. When this angle of incidence increases, the reflected ray, corresponding reflected ray move or makes 90-degree angle. This is I, and when it is 90-degree angle, this I is known as critical angle. Once again, this is a source, a beam of light, a ray of light, incident ray, incident on a denser medium, and it bends away from the normal. On increasing the angle of incidence, angle of refraction also increases. And at a particular value of angle of incidence, the refracted ray bends at 90-degree angle. Now this angle of incidence is also known as critical angle. The angle of incidence whose corresponding angle of refraction is 90-degree and the rarer medium is known as critical angle. This is the definition of critical angle. And remember that if we increase further just 1 degree or more than 1 degree, if we keep the angle of incidence greater than critical angle, and critical angle is that angle, actually critical angle is an incidence angle but conditional. The angle of incidence is also known as critical angle if its corresponding angle of refraction is 90-degree. And if we increase the angle of incidence, if we kept the angle of incidence greater than critical angle, then the entire light comes back into the denser medium. Like this, if we increase the angle of incidence, this is normal. Now here angle of incidence is greater than critical angle. Now the light does not bend. Even that this is not a mirror, this is glass, transparent material or medium, and light should pass through this medium because it is a transparent medium, not a reflected surface. But at this stage, when we increase the angle of incidence, when we kept the angle of incidence greater than critical angle, the entire light comes back into the denser medium, obeying the laws of reflection of light. Obeying the laws of reflection of light. And in laws of reflection of light, first law is that angle of incidence is equal to angle of reflection if the surface is smooth and flat. And here R, this is R, reflection of light. This return of light into the same medium after striking with some transparent material is known as total internal reflection. The light comes back into its original medium from which it was originated. Is this phenomena is known as total internal reflection. Incident ray falls on the denser medium, bends away from the normal. If we increase the angle of incidence, angle of reflection also increases, and at a particular value, angle of incidence is also known as critical angle because its refracted ray makes an angle of 90 degree. This is known as critical angle. And if we increase the angle of incidence, then the critical angle. If angle of incidence is greater than critical angle, the entire light comes back towards its original medium, that is a denser medium. This phenomena is known as total internal reflection. You can say when the angle of incidence becomes larger than the critical angle, then the entire light is reflected back into the denser medium. This is known as total internal reflection. Inshallah, tomorrow we will study our next topic, whatever I think its applications of total internal reflection, like totally internal reflecting prism, optical fibers, and periscopes, binocular, in which this phenomena will be used. Okay, Allah Hafiz.